The client is a large curtain wall manufacturer. They're actually based out of Canada. They have a unique offering and it's very diverse. And they were doing everything basically by hand. So the initial call was from a plant manager. They wanted us to kick around some ideas of how to increase their production quality and to try to figure out a way to take things out of the operator's hands. So currently they were handling one stick at a time going through the machine, and they could have had 10 or 15 different profiles. So our philosophy was, well, why would you do one stick at a time? We could make the machine be capable of doing 2 pieces at a time, which are mirrored or the same cut length. You get those out, there's 2 pieces rather than just one and then have to match it up with its pair later. The customers' initial reaction of the concept that we threw out to them was they were a little reserved on it until we were able to explain to them and kind of go into more detail of, okay, this is one machine that has 5, 6 different tools changing in it. It can do multiple sides of the part at a time, 2 pieces at a time, and I can program it to do basically any cut length or anything I want it to do. I think that was the turning point of it, that it was just so flexible. The challenge is there's so many different ranges of things that have to happen, fabrications, sizes of parts, fixturing the part, holding it, clamping it, and knowing where the tool locations all have to go. That was the trick of the machine, but it was also the part of the machine that was the selling point that made it flexible, that made it capable of doing what other machines couldn't in the same time or faster. The 4-axis tool in the machine allowed us to move in an X, Y, and Z direction. That's the 3 of the axes of the tool. And then the 4th axis of the tool was actually the head could actually rotate to the sides. There is a pusher axis as well, and the pusher axis actually moves the stick through the machine. So you have saw blade, moving tooling station, and then pusher. Within that tooling station and the saw, we could do all of the fabrication, then it would step to the saw and cut off the finished part. The goal is to basically make it like a black box for them. They put a stick of material on, they go collect a finished good quality part that's ready for assembly off the back of the machine. We were able to hit their tolerances. So through the course of a day, they're not spending a lot of time on reworks. They are able to focus more on the end product, their end product, which is the importance. To maximize yield of the equipment, we do have, from a software standpoint, we have optimization features. Basically what that does is it takes all of the products that will get cut out of that particular sticks of material. It will organize them based on cut lengths and fabrication to minimize that scrap, to maximize the yield of that stick. And in this particular case, that was very important because there is so many pieces in a project. The less the operator has to load it, with the more pieces they get out of a stick, the better off the throughput will be. This machine was very universal in nature to where things could move around, be manipulated, be modified easily to adapt to different products. And in fact, they had changed products over the years. Flexibility in programming, flexibility in mechanics was how we achieved that. And that's all on the upfront thought process. The biggest benefit, in my opinion, of Joseph is just our team. Every single person in this company gets involved, and ultimately we want the customer to be happy. So our goal is to partner with you through the design process. So we want the customer to have a machine that is going to be what they want it to be. That's where I think we thrive the most, is how we work as a team with internally and with the customer.